Chapter Special Factoring. So this is part of our factoring unit. We did some basic factoring last time, and now we're going to do what's called special factoring, but really it's not any different. Though near the end there is something, composite functions, that we are going to factor. And using the method that I've done in the first section, it kind of makes it almost exactly the same. There's maybe a couple extra steps, but really the basic idea is the same. The very first question is looking at something called difference of squares. A difference of squares is, take a look right here at the very first example, is one where you see an x plus 3 and an x minus 3. So where they both have an x, and then one is plus and one is minus, and the number is the same. Now look what happens if we multiply. X times x is an x squared. X times negative 3 is a negative 3x. 3 times x is a positive 3x. And 3 times negative 3 is a negative 9. And these are alike. So you get x squared, negative 3, and positive 3 will cancel out, and you're left with an x squared minus 9. So this is a trinomial, but the middle terms ended up getting canceled. So it doesn't look like a trinomial meaning something with 3 terms. There's only 1, 2. So there's only 2 terms in here, but it still is a trinomial where that middle term is 0. You could write it as x squared plus 0x minus 9. That's also an option. We just don't write the 0x. 0 times anything is 0 and it's gone. So another trinomial here, or another multiplying. 2x times 2x is 4x squared. That is a negative 6x. This is a positive 6x. And that is going to be a negative 9. Again, these are alike. It's negative 6 and plus 6. We can add them, but they're going to cancel out. So you're left with a 4x squared and a minus 9. So like the other questions, I don't know if I can look here. This is some of our previous ones. There were 3 terms, and we could use this method of factoring. But now we're going to be given something like this, and it's only 2 terms. But we can still use the same method. Let's try the third question here, multiplying. 2 times 2 is a 4, x is x squared. That is a negative 6xy. This is a positive 6xy. These are alike, so we can add them. Negative 6 and positive 6 is 0, so we cancel them out. And then a negative 9y squared. So my answer is 4x squared minus 9y squared. So again, we haven't factored anything. We've just done multiplying. But what's interesting to note is that these are called difference of squares. Difference meaning all of these things will have a subtraction sign. And the numbers are perfect squares. 4 is 2 squared. 9 is 3 squared. And so all of these here, x squared minus 9, there's a difference there. 9 is 3 squared. There's a 1 in front. 1 is 1 squared. So these are things that we can factor. So again, there's the very first example here. There's only 2 things. But that's because the middle term is gone. This could be written as x squared plus 0x minus 16. So we want to try to factor this. And using our method that we did before, we've got x and x. That will multiply to the x squared. And then we need 16. Well, 16 can be 8 and 2 or 4 and 4. So let's just try for the sake of this, 8 and 2. But one of them has to be negative, so we'll make that negative. This diagonal is a negative 2x. This diagonal is a positive 8x. And I get 6x. But that's not what I have. That's not what I need. I need whatever's in the middle. There is no middle. I need a 0. So the only way to get the 0 is to have 2 of the exact same numbers. If you notice here, 3 and negative 3. You have to have the exact same numbers, but one of them has to be positive and one of them has to be negative. So I'll do 4 and 4, where one's positive and one's negative. Then when I do my diagonals, I get a negative 4x, positive 4x, and that, if you add them, get you a 0x, which is why that middle term is gone. The 0x is right there. There is no term. So that's exactly what we're looking for. We got here and here, x plus 4 and x minus 4. So is this really any different? No. there's only 2 terms here. Normally we've had 3 terms. Here we only have 2, but we have to notice that that middle term is actually gone. It's a 0. And you're going to start to do this, you're going to become really, really fast at these, because you're going to notice, oh, 25 is a perfect number, perfect square. It's 5 times 5. 1 has to be negative. 9 is a perfect square, 3 and 3, x and x. And then if you do that, because they're the same, 3 and 3 and 5 and 5, when you do your diagonals, you get 15 and 15. But one's positive and one's negative. So a negative 15 and a positive 15, that's going to get you a 0. And that's exactly what we have in the middle. We have 0. That middle term is missing, a 0x. So that's perfect. We've got a 3x minus 5 and a 3x plus 5. So 3x plus 5 and a 3x minus 5. So let's do one more here. Factor this. Oh, I'm missing a middle term. And I noticed that 25 is a perfect number, 5 and 5. X and x to get x squared. 36 is a perfect number, 6 and 6. Y squared is y and y. Because it's minus, I have to make one of them positive and one of them negative. It doesn't matter. My diagonals are a 30 xy and a negative 30 xy, which is a 0 xy, which is exactly what I have. I'm missing that middle term. It's 0. So I know I'm okay. So I have a 5x minus 6y and a 5x plus 6y. So I've said this again. I said this before, and I'll say it again now. This is very messy. Luckily, I have some neater notes that are already online. But I'll zoom out here. These top questions aren't going to be on the test. That's multiplying. You do that in grade 9. That's not what we're doing here. That was just to show you what happens when you have the exact same thing, 2 and 2, 3 and 3, with one of them plus and one of them minus. What ends up happening? That middle term disappears. So that was the whole point. The questions that you need to understand how to do are A, B, and C. And we'll do more in the next video.